August 15th, 1977. A radio telescope in Ohio is quietly scanning the sky, like it does every night, listening to nothing but static and background noise. Then, for exactly 72 seconds, it picks up something else. A signal. Strong, structured, coming from deep space. The astronomer reviewing the printout the next morning circles the data in red pen and writes one word next to it. Wow. Nearly 50 years later, no one has ever heard it again, and no one can tell you what it was. To understand why this signal broke people's brains, you need to know what scientists were actually listening for. Since the 1960s, a small group of astronomers had been pointing radio telescopes at the sky, searching for one very specific thing, a signal that couldn't be explained by anything natural. Not a star, not a pulsar, not interference from a satellite or a passing plane. Something artificial. Most nights, they got exactly what you'd expect. Nothing. Just the low, meaningless hiss of the universe. The telescope doing the listening that night was called Big Ear, a massive flat radio dish built into a field in Ohio. Part of a project called SETI, the Search for Extraterrestrial Intelligence. It didn't watch the sky in real time. Instead, it recorded data onto paper printouts, line by line, that a researcher would review days later. Which means when the signal actually happened, nobody was even watching. It was already gone by the time anyone knew it existed. On the night of August 15th, the telescope was pointed toward a cluster of stars in the constellation Sagittarius. Not because anyone expected to find anything there, but because that's simply where the scan happened to be sweeping. For most of the night, the printout looked like every other printout. Rows of numbers, mostly single digits, representing background radio noise. Nothing above a 1 or a 2 on the scale researchers used to measure signal strength. Then, for one brief window, the numbers climb. 6, 14, 19, 26, and then, unmistakably, U. On the scale being used, letters represented signal strengths so far above normal that there weren't enough numbers to describe them. A U meant the signal was 30 times stronger than the background noise of the universe itself. It held that strength, impossibly strong, impossibly clean, for the full 72 seconds the telescope was pointed in that direction. Then, as the Earth's rotation carried the dish's view away from that patch of sky, the signal vanished. 3 days later, astronomer Jerry Eman was reviewing the printout by hand, the normal, tedious process of checking days' worth of data for anything unusual. When he reached that row of numbers, he didn't write a report. He didn't call a meeting. He picked up a red pen, circled the sequence, and wrote a single word in the margin. Wow! That word is the only name this signal has ever had. Here's what made it truly strange. Not just that it was strong, but what kind of signal it was. It came in on a very specific frequency, 1,420 megahertz. That's the frequency at which hydrogen, the most common element in the universe, naturally emits radiation. It's a frequency so fundamental that scientists had long theorized it would be the logical choice for any intelligent civilization trying to send a signal across the stars, because any other civilization advanced enough to listen would already know to look there. The wow signal wasn't just strong. It was tuned to exactly the frequency you'd choose if you wanted to be heard. And then, nothing. Astronomers pointed telescopes back at that exact patch of sky again and again. Over the next several decades, they tried more than 100 times. It has never repeated, not once.